Hello YouTubes, this is Professor Vaganov and this is going to be another lecture. This one will be about debugging basics. I'm going to start this lecture with a little bit of a review. I'm going to build a new project so that I can show you guys a program to debug. And I'll call this Debugging Basics. Okay. I'm going to make a new main.cpp in here. I'm going to build a Hello World program. And let's run that and see how it goes. Yep, looks good to me. There's not much to this program though, so I'm going to make it a little bit more complicated. I'm going to make a couple variables, like an integer. I'm going to call it number. I'll make a character called letter. I'll make a floating point variable called decimal value. And then I'll try to use these in my program. So I'm going to type enter a number and enter a letter and enter a decimal number. Cin number, Cin letter, Cin decimal value. And let's run that and see how it works. Well, it'll work and we won't really see anything. 1, 1, 1. That'll actually work correctly. The reason all ones will work is because 1 is simultaneously a number, 1 is also a letter, there's the letter 1, and 1 is also a decimal point number, it just has no decimal values. If I print it out, number, letter, and decimal value, now we can see output. Let's do that 1, 1, 1 thing again. Check that out. I didn't even have to press enter between those. The way that Cin works is it expects input from the user, and whatever the user puts in there, it stores in an input buffer. So this right here says grab data out of the input buffer and put it inside of this number. And if there's already data in the input buffer, it'll just take data right out of the input buffer. So when I did the 1, 1, that second time Cin ran, it was able to look in the input buffer and recognize that there is indeed a letter in there called 1. A letter in there whose value is 1. So it put that value inside of letter. And now it's waiting for a decimal number here because I only put 2 values separated by spaces and end line. Cin ignores white space and it separates values by white space. So if I put 1.1 in here, that will work correctly. I will run this code again with some different values so that we'll see that it's not just 1, 1, 1 that works. I can use 1 and x and 3.14. And there, each of those are differently printed out right here. The 1 is the number, the x is the letter, and the 3.14 is the decimal. Now if I changed this up and instead I did it, for example, in reverse order, 3.14, check that out. It finished. It said 3, period, and 14. 3 is the number, dot is the letter, and 14 is the decimal value. I'm going to change this code a little bit so that we can see a little bit more clearly how that works, or that it did work that way. Let's try that. 3.14. Check that out. 3.14. The way that cin works is when you try to give it an integer, it grabs as much integer data as it can, and it stops as soon as it finds something that isn't an integer. The period right here does not belong to an integer, so it stops reading it. However, when cin is looking for a letter, the period, which is still inside of the input buffer, that does count as a letter, so that gets stored inside of letter. And then when cin is looking for a decimal value, again, it looks inside of the input buffer, sees that there's already data there, and that data could actually be a decimal value. In this case, it doesn't have a decimal point, but it can store it inside of my decimal value variable just the same. And I can prove that that's the behavior that's going on in another way using the debugger. Let me show you how to activate the debugger. It's actually pretty easy. You can get the line numbers to show up if you just go to Tools, Options, Text Editor, C++, General, and here I've got this right here, this check mark shows the line numbers. If you're using a different IDE, like Eclipse CDT, there's going to be a very similar area where you can find the line numbers to show up. Every IDE has this feature, so if you look hard enough, you'll find it. But anyway, the debugger, the way that you access it is over here to the left of the line numbers, or just to this on this gray area. If you don't have the line numbers, you can click, and when I click, a little dot shows up. This dot right here is a breakpoint. If I run the program in debug mode, I can go to debug, start debugging, or I can just press F5. When it starts up, it will stop as close to that debug marker as it can. And at this debug marker, if we look at our program, we'll notice that it hasn't done anything. The program is running, but it's waiting here. It's waiting for me to tell it to continue executing the line. If I hold my cursor over these values, my mouse, we can see that they have actual values in there. This is garbage data. Right now it's waiting to execute this line. It's waiting to do enter a number. If I want to continue executing the code, I can do so with these three options here. This one right here is the step into option, and this will allow me to go into the output operator function and see how the output operator function works. This step over will allow me to skip this line and just let it do its thing. And this one right here will let me get out of this function and just assume that I don't want to see any more of it. Let me show you how these three work. So right now it's waiting here at cout, and it's waiting to see what I want to do. Well, I'm going to step in and see how cout works. And it takes me here into where is it? Basic O stream. Here we go. Operator less than less than. If you guys saw my Hello World lecture, you may have seen that this is actually what's going on whenever it uses the output operator here. It's calling this function where it's putting cout as the output stream, and then it's the value that it's putting in here in this case is this string enter a number. And if we hold our cursor over val, it's exactly what it says, enter a number. But this is like really crazy looking code. It's almost impenetrable. For the most part, you can ignore the code that belongs to files that you've never seen or you've never written. And when you get to one of these functions, you could, if you wanted to, continue stepping into the code and see how it does one line at a time. And it's calling other functions. Here it jumped into some assembly code, some inline assembly code. But eventually, wow, it's doing a lot of assembly code. Eventually you'll get tired of this stuff, especially if you don't understand it, and you can just step out. Step out says, okay, thanks for showing me this code. I'm not interested in this function. Go back to the function before this one. That's what I actually cared about. So here, the output operator actually went into another function called length, probably finding the length of the string, of the null terminated string. Yep. So I don't want to see this function either. Let's just jump out of this output operator. I'm not really interested. I'm going to just jump out. And you know what? I'm not interested in this line at all. I'm just going to step over it. So when I step over, it's going to make me skip this invocation, because this is another function here. We just saw this being run, and then if I did another step in, it'll show me this being run. I'll just show you that's exactly what would happen. Step in, and here we are, output operator again, and this time it is, wow, this is crazy. Yeah, I have no idea what all of this means. I'm just going to step out of it because it's just scary, and I'm going to step over this function because it's just nuts. Once I step over the line is finished executing. This line right here is supposed to print out to the console, and we can see that if we look at our console right there. It says enter a number. The next line, cin number, is supposed to wait for us to enter a number. Again, we can step into this and see all the crazy stuff going on in here. This is operator greater than. It's the input operator for cin, but again, I'm just going to step out of it because I don't care. Now it's waiting for input because it's executing this function. It's executing cin number, and it's waiting for a number. So I'm going to give it the number 8. Enter. And now, if you look at your start menu, it might be blinking because it got data in number. And now if we hold our cursor over number, we notice that it's 8, which is the number that we gave it. Letter is still some crazy gobbledygook. Decimal value is still garbage data as well. But number is good. Alright, so far this seems to be working. I'm going to step over cin. I don't care about the rest of it. And then there's cout. Notice cout has not run yet. I'm going to step over it, and there we see enter a letter. I'll step over letter, or at least try. It's actually waiting for letter now. I'll enter shift 8 and it'll give me an asterisk here. And then when I'm done, letter now is 42, which is the star. Now it's printing out some more. I'll step over this and try to step over this. It's waiting for a decimal value, 1.11111. Why not? Now decimal value has that value. It hasn't executed the cout statement yet, but it's waiting to. And if I stepped in, I'll just step in and see what happens. Oh, it's the same gross thing. I'll step out and look over here, and it printed 8 right here. It printed number. The next thing it needs to print out is this, and if I step in and step out, there it is. There's that string literal that I put in here. And if I step in and step out, then it prints letter, which is the star. I'm just going to step over though. I'm just going to assume that it's working correctly. So I'll step over. And here we go. It finished printing everything. When I'm done and I don't really care about stepping through lines anymore, I can just hit continue, and it will continue as though I weren't in debug mode and just run the code as it's supposed to. And now it's waiting for me right here at the getch. So I'll go ahead and press a key, and that's that. If I started debug mode and I started doing things and I decided to stop debug mode and I decided to quit, I wouldn't be able to close the program here. This is bad. Trying to close the program here may freeze up the computer. It'll certainly lock this program up. The right way to break out of debug mode is to hit this stop sign right here, the stop debugging, which is to the left of these step buttons. And actually there's another continue button right there, which is the same thing as that. So I'll just hit stop debugging. So that's how the debugger works, and we can use that to look at problems as they're happening. It doesn't necessarily solve our problems, but it lets us understand more clearly how the program is working, and that understanding is how we actually solve problems. Let me show you a bug, what we call a runtime error, that can happen while you're making one of these programs. I'm going to go ahead and run the program. Hit F5. By the way, I took off that breakpoint so it doesn't stop anymore. And instead of entering a number like it's asking me to, I'm going to enter a letter. And now check that out. Look at all that craziness right there. Garbage data. When it asked for a number, I gave it a letter, and then cin just kind of threw its hands up in the air and said, you know what? I've had enough of you. No more. I'm not even going to pay attention to you anymore. I'm just going to stop working forever. And all of these variables, I don't care what they were before, you don't get to change them. That's just the way it is, which is kind of sad.